All right, everyone. Today we are going to be working on lesson 5 in booklet 8. That is adding and subtracting fractions. But unlike the last lesson where we're changing two denominators, here you only need to change one of your denominators in order to have the same denominators, right? So this lesson is going to be a little bit trickier than the last one, but it's important because if you get really good at changing only one of your denominators, then oftentimes it can save you a lot of time. So here we are with two fractions that we're adding, 1 over 3 plus 3 over 6. Now, in the last lesson, if you were to add these two fractions, what you would do is you would multiply the first fraction by the second denominator and multiply the second fraction by the first denominator. In this lesson, we're not going to quite do that. We are going to find a different, potentially faster way to find the same denominator, and we're going to do that through skip counting. So let's talk about that first. When I say skip count, I mean counting not by ones, but counting by twos, threes, fours, or any other number that's not counting up by ones. For example, if I asked you to skip count by 2, then that would look like 2, 4, 6, 8, 10, 12, 14, so on and so forth. If I asked you to skip count by 3s, that would be 3, 6, 9, 12, right? Just adding 3s every time, so on and so forth. If I asked you to skip count by 4s, that would be 4, 8, 12, 16, 20, 24, so on and so forth. Now, why is that important? The first thing that you're going to do when you have two fractions that you're adding or subtracting is you're going to see if the smaller denominator can skip count into the larger denominator. Okay? So in this case, our smaller denominator is 3, and our larger denominator is 6. So the question is, does 3 skip count into 6? Well, this question's pretty straightforward. The answer is yes. 3 does skip count into 6, and pretty quickly, right? If I was to start my list of counting up by 3s, that would be 3, 6, and I'm already there. I only need to skip count twice. So, if the question is, does the smaller number skip count evenly into the larger denominator? The answer is yes, 2 times. Okay. If you need to, another way that you can calculate this is you can take the larger denominator, which is 3. You can divide it by the smaller number, which is 2. Oops, sorry. You can divide it by the smaller denominator, which is 3. And if 3 skip counts into 6, then your calculator will give you a nice number. And when I say nice number, I mean not a decimal. So 6 divided by 3, that gives us a nice number. That number is 2. Conveniently, the same number of time that it takes for 3 to skip count into 6. But either way, you just need to be able to tell me that 3 skip counts into 6 2 times. So what you're going to do is you're going to take that number, which is 2, and you're going to multiply only the first fraction by 2. You're going to multiply the second fraction, the one with the larger denominator, by nothing. So this saves you a little bit of time if you're really good at skip counting. So I multiply the first fraction by 2, and that's all that I need to do to get a common denominator. You can see that here they both have a denominator of 6. So now that we have the same denominator, all that I need to do is add these two fractions. 2 over 6 plus 3 over 6 is equal to 5 over 6. All right, let's try that a couple more times. Here I have 7 over 8 minus 1 over 2. We're not going to multiply the first fraction by 2 and the second fraction by 8. Instead, we're going to take the smaller denominator, which is 2, and we're going to skip count, see if we can get to 8. So we're going to skip count by 2's, which would be 2, 4, 6, 8, and we're done, right? We have successfully skip counted to the larger denominator using the smaller denominator, and it took us 1, 2, 3, 4 times. Remember, an alternative way is to take the larger denominator, see if you can divide it by the smaller denominator, and if it gives you a whole number, that is the amount of times that it would take you to skip count. Either way, 2 times 4 is going to give us 8. So I take the smaller fraction, or rather the fraction with the smaller denominator, and I multiply that by 4 in order to give me that same denominator. The fraction with the larger denominator stays the same. 1 times 4 is 4, 2 times 4 is 8, and now that they have the same denominator, I can subtract 7 and 4 to get 3, and the denominator stays the same. Okay, this does take a little bit of practice, so try the next couple examples and then make sure that your answer matches mine. In this first example, we are skip counting by 4's, right? So that would be 4, 8, 12, and then we're done. We successfully skip counted into the larger denominator. This took us 3 skip counts. So we're going to multiply the smaller fraction by 3. 3 times 3 is 9, 4 times 3 is 12, and remember, when you're using this method, the fraction with the larger denominator does not change. Now we have a common denominator of 12, so we can subtract the two fractions. 9 minus 2 is 7, and the denominator stays the same. In this last example, the smaller denominator is 4, so we, again, are skip counting by 4's. We're trying to get to 8. This happens pretty quickly. We only need to skip count twice. So that means that we multiply the fraction with the smaller denominator by 2, giving us 3 over 8 plus 4 over 8, or 7 over 8. And that's about it. Take some time to complete the following worksheet, and as usual, if you have any questions, please let me know.